Well, happy Friday to you. It is Geospatial 2.0 Friday talk time, and we've got a pretty serious topic that I'm going to discuss today. Our topic title is, does GIS have a massive, potentially life-threatening data problem? This is part one of two. I'm actually going to do a second one after this, which will carry on from this one. I'm using the word GIS here because a lot of the data that is in use today has a GIS base to it. I could have used the word geospatial there. So let's move ahead. So 40 plus years actually of digital data collection and creation is what we've experienced within the GIS industry. So, you know, examples of how we've collected data, we've pen and paper, we've got digitizing. I remember actually digitizing when I was at college and actually as a job for a little while. And then more latterly, we've had the ability to collect data via handheld devices. That started many years ago and continues. So there's lots of ways that we've actually created and collected and created the data we've now got, geospatial data and GIS data. And that data has various levels of accuracy. So what I'm going to talk about actually here is around accuracy. And in fact, as I've got at the top here, accuracy is not the problem I'm going to be focused on in this talk. The big problem that we're facing, the potentially life-threatening problem we're facing, is that too often we don't know the accuracy of the data that we're using. So as an example, and again, some of what I'm telling you today is based on conversations I've had over the last week or so with various folks. So this is really bringing some of that stuff together. But for example, if you're using line data that's in a GIS and someone questions you about the accuracy of it, more often than not, and I've seen this before, people will sit an actual image beneath it. Let's say it's of a pipeline. So we've got a line that goes over a pipeline, and by putting an image underneath that of that actual pipeline, that justification is, we'll look at the accuracy of that line data. But do we know how accurate that imagery is? Just because we can overlay vector data on top of imagery, we presume it's accurate, but we don't know the accuracy of the imagery. So there's an example. I fear that we have a lot of times no idea of the accuracy. So therefore, the obvious question to ask is, if we don't know the accuracy, how do we know if it's fit for the purpose we intend to use it for? And I will underline that, fit for the purpose. So let's talk about a specific use case, safety of life purpose. If we don't know the accuracy of our data, is it fit for a safety of life purpose? Question. The obvious answer to that is absolutely not. In fact, you're ethically obliged to know the accuracy of your data. If there are lives at stake with the data that's being used and you don't know the accuracy of it, you're ethically obliged to not use that data, or at least if you're going to use it, to know how accurate it is. So we've got an increasing number of use cases out there. We've got autonomous vehicles here, cars on the road, public vehicles on the road without drivers. Those rely on a foundational data set or a group of foundational data sets. There are pipelines, gas pipelines. Do we know where they sit under the ground? If we don't and we hit one of those pipelines, guess what happens? Lives are threatened. If we're using data that we don't know the accuracy of in autonomous vehicles, guess what's going to happen? Lives are threatened. This is a really big topic. So, the solution. Number one is to recognize the problem. And again, I do these talks to raise the question. Now, again, I will underline that we do have a problem. This isn't me speculating. We have a problem. The extent of the problem, I don't fully know, but we do have a problem. The second part of the solution is to use Geospatial 2.0 data and technology, that is highly accurate sensors and artificial and machine learning, to determine not only the accuracy of the data, but to improve it if it needs to be improved. So we have a perfect situation here where we can use modern technologies, and this is sensors from space to aerial to drones to terrestrial, highly sensitive, highly accurate sensors with the automated processes that can artificial machine learning can process that data. Pretty hard-hitting stuff. That's my email address. That's me. I'm interested in your thoughts. I'm interested in your feedback. Agree, disagree. Are you coming across scenarios where you don't know the accuracy of the data and it worries you because you know the purpose of use of that data is in potentially safety questions, life and safety questions? Like I said, this is the first of 2 videos. I'm actually going to follow up with a second video, which is actually addressed directly to the geospatial industry, another really important topic. And again, it's a follow-on from this.